Hello there, welcome to my channel on chemistry lessons. If this is your first time, welcome. If not, welcome back. But this channel provides material, full lesson material and revision material for all chemistry topics. I aim to be uploading regular videos to help and support you with your A-level chemistry as well as your BTEC applied science. So please subscribe so that you don't miss out on future videos, and also use the comments features to let me know of topics that you think would be useful in the future. Good luck, and I hope it's useful. This is a BTEC applied science video and focuses on the Unit 1 Chemistry Assessment Objective 2, and it's lesson 7 in a series of 8. This lesson covers redox, oxidation, reduction, half equations and assigning oxidation states. So just to remind you of the specification then, whenever you're revising, you should always have a very clear list in front of you of what you're supposed to be able to do. And with Unit 1, the chemistry is split into two sections, A1 and A2. Now this series of videos just focuses on the A2, and there are 8 lessons in total. There will be other videos for the A1 topic. So this is the full list of things that you should be able to do from Assessment Objective 2. Now the first 6 videos focus on this section. We've covered all of this section, and the last video that you looked at was the reactivity of metals. So we looked at the reactivity of metals with oxygen, water, acid, and being able to use the position of the periodic table and position in the reactivity series. Today's lesson is going to look at oxidation, reduction, and variable oxidation states of transition metals. So we're covering these 3 bullet points today. So there we go. We're going to look at oxidation, reduction, and oxidation states. There's 2 key parts to this topic then. First of all is getting used to some new language that you won't be familiar with and what they mean. And the second part is going to be to actually come up with some rules of how we assign oxidation states. Let's look at these key terms then. So the term redox, that is the name given to a chemical reaction that involves the movement of electrons or the transfer of electrons. So a redox reaction involves the movement of electrons. And we can break that down into 2 terms. Reduction means electrons are being gained during a reaction, and oxidation means electrons are being lost. Hence the term redox, reduction oxidation. It's a reaction that involves the movement of electrons. And there's an easy way we can remember this. Remember oil rig. Oxidation is loss of electrons, and reduction is gain of electrons. So we need to know and be able to use those terms, oxidation and reduction, in terms of electrons. We also need to go one step further and be able to construct half equations to show oxidation or reduction. So more on half equations then. So what is a half equation? Well, a half equation will either show oxidation or reduction. And remember, oxidation is loss, reduction is gain. So we're going to look at something losing electrons. Now, metals will generally lose electrons to become positive ions. We have seen that. So I'm going to use an example here of lithium losing an electron to become lithium plus. So to show that happening, we show the electron being lost at the end. So an oxidation equation will have the electrons part of the products because they're being removed. So this shows lithium going from lithium with no charge to lithium losing electron and becoming positively charged. I could also pick a group 2 metal such as calcium and show calcium becoming 2 plus by losing 2 electrons. Now reduction is the gain of electrons. So what I'm going to do now is look at something in group 7. Fluorine is in group 7 and it exists as F2. It will gain electrons to become F-. It will become fluoride ions. It will gain electrons. Now, I need to make sure this is balanced because at the start I've got 2 fluorines and only 1 fluoride. So to balance it, I do need to put the 2 in front of the F in the products to show that I've got 2 Fs on both sides. Now what I need to do is show that it's gaining electrons. But in fact, I need to show 2 electrons being gained because there are 2 Fs. Both of them are gaining 1 electron. So F2 plus 2 electrons becomes 2F minus. I could also show something like oxygen. Oxygen will become oxide, or 2 minus. It's in group 6, it will gain 2 electrons. Again, to balance it, we're going to need a 2 in front of that one. And each oxygen will be gaining 2 electrons, so in total we have 4 electrons being gained. It's going from O2 to 2O, 2 minus. So each O has gained 2 electrons to become oxide. Time for you to have a go then. So pause the video and you're going to try and draw half equations for these 5, and also once you've drawn the half equations, identify them as oxidation or reduction. Question 1 then. Na, it's going from no charge to a positive charge, which means it's losing an electron. So I need to put the electron on the right hand side, and that is an oxidation. Second one, aluminium, is becoming 3+, it's losing electrons, and it is in fact losing 3 electrons. So that also again is an oxidation. The third one, it's becoming negative from neutral, so it's gaining electrons, but I must make sure it's balanced, so I need to put the 2 in front of the Cl minus and a 2 in front of the electrons, because there are 2 chlorines and each of them is gaining 1. Question 4, N2, it's becoming N3 minus, again there's 2 N's here and only 1 N here, so I need to put a 2, and each of them are gaining 3 electrons, so I need to put 6 electrons here. And finally, the last one, we've got iron 2+ becoming iron 3+. So what's it doing? It's becoming more positive, which means it's losing an electron. There's only 1 electron involved there. Okay, final term for us to look at then, oxidation state. Now the oxidation state, it's telling you how many electrons have been gained or lost by that atom. So for example, all elements will have oxidation state 0 because as elements they haven't gained or lost any electrons. So all elements are 0. That's our number 1 rule. So all elements are 0. Second rule is that group 1 will react to form +1. So group 1 will be +1 in compounds. So anything that's group 1 will be +1 in a compound. And likewise, group 2 will be +2 in compounds. So for example, sodium is in group 1, but sodium as an element will be 0 because it hasn't lost its electrons yet. However, group 1 in a compound such as sodium chloride or sodium oxide, sodium will be +1 because it will have lost its electron in that chemical reaction. It will have released the electron, it would have lost them, it would have been oxidized. And we can say the same for group 2. They will lose 2 electrons. Now when it comes to group 7, they like to gain electrons and therefore they will be -1 in compounds. And similarly, group 6, they will like to become -2 in compounds. Now I'm going to refine these rules a little bit in a couple of slides time, but that's generally true. The only ones we're going to look out for really are these last two. I'm going to put a couple of exceptions later on, but that's a good rule of thumb to start with. Group 1 will always be +1 in compounds, group 2 will be +2 in compounds, group 7 will be -1 in compounds, group 6 will be -2. That's all about the gaining and losing of electrons. Group 1 will lose 1 electron, group 2 will lose 2, group 7 will gain 1, group 6 will gain 2. We see that about getting that full outer shell. So that kind of does link to our work in GCSE and our work in assessment objective 1. Okay, so let's look at those kind of exceptions and let's try and bulk those rules up a little bit more then. So we're gonna leave group 1 and group 2 as they were, because they will be +1 and +2. But I'm going to introduce a couple more that we'll look at. So we said group 7 will always be -1, but it's not always the case, unfortunately. So F will always be -1 when it's combined. So F is up at the top. So F will always be -1. So F will always be -1 in compounds. And when we look at group 6, oxygen will always be -2 in compounds, except when it's with fluorine. So except with fluorine, because F will always be -1. So sometimes oxygen, if it's with fluorine, will not be -2. Okay. There's also one other exception for oxygen, is when it's in hydrogen peroxide. And that's because hydrogen, combined hydrogen, is always +1. So hydrogen compounds will always be +1. So if hydrogen is +1 here, that means that the oxygen now is -1 and not -2. So there's some exceptions to look out for. Okay. And likewise, we'll look at chlorine now. So chlorine is always -1, except when it's with oxygen or fluorine. I'm going to leave us with those exceptions. Okay, so fluoride is always -1, no exceptions. Oxygen is always -2, except if it's with fluorine or in peroxide. Hydrogen is always +1. There is one exception that I don't really think we need to worry about, metal hydrides, in which case hydrogen does become -1, but I don't really want us to worry about that now. We're going to focus on our applying of the rules in our non-metals right now. And chloride, always -1, except when it's with oxygen and fluorine. So it seems like there's quite a few exceptions, and I agree there are. Okay, so what we're going to do now is we're going to look at applying or assigning oxidation rules using what we've just learned here, using these rules. Okay, so what we're going to do is I'm going to give us some substances here, and we're going to identify the oxidation states in each of these substances. I'm going to do one tricky one. Okay, so let's look at the first one then. Na, this is a compound, so they're combined. Na is in group 1, so it's always +1. Chloride is always -1, except when it's with oxygen and fluorine. It's not with oxygen and fluorine here, it is -1. And the sum should add up to 0, because there's no charge here, look. Number 2, O2. Now this is an element, so it is 0. It's just an element. Elements have oxidation state 0. Number 3, we've got compound. Now we've got oxygen. Oxygen is always -2. So oxygen here is -2. We've got 3 of them, look. So we've got 3 of them. You can see it as the charge. It is the charge. It's going to be -2. Aluminium, well, that's got to be +3. We've got 2 of them, and that's +3. So the oxidation state of aluminium is +3. the oxidation state of oxygen is -2. That's in aluminium oxide. Number 4, FeO. Well, O, this is a compound again. O is always -2, except when it's with fluorine or peroxides, and again, it must be balanced to 0, so that means iron must be +2. So the oxidation state's here, iron is +2, oxygen is -2. And this one here is really difficult actually. Well, oxygen is always -2, except when it's with peroxides or fluorine, which is not the case in this one, so it's always -2, it's going to be -2. Potassium is in group 1, so it's always +1. And now what we need to do is we know that all of these must add up to 0. That means that chlorine is +5. Now that's confusing, that's difficult. And the reason chlorine isn't -1, because it usually is -1 unless it's with oxygen or fluorine, and it's with oxygen in this case, so it's not -1. It actually works out in this case to be +5. So that oxidation state of chlorine is +5. That is difficult, okay? Okay, so this is going to be a quick task for you. You're going to identify the oxidation state of each element in each of these species or compounds. So what you're going to do is pause the video and you're going to identify the oxidation state of each of these elements in all of these 4 compounds. When you're ready, unpause the video. Okay, first one, H2O, water. Oxidation state of oxygen is always -2, hydrogen is always +1, so there's our oxidation states. +1 for hydrogen, -2 for oxygen. Question 2, we've got a group 2 metal which will be +2, and we've got oxygen which will always be -2, and they add up to 0, so you can always check at the end to make sure you're right, because they should add up to whatever the charge is, and these are all 0 charge. Water doesn't have a charge, so the sum must add up to 0. So double check your answers there. And it's probably worth pointing out that if you're trying to do this without a periodic table, you won't be able to. Number 3. So oxygen is always -2, except when it's with fluorine or peroxide, and it's not. Chlorine is always -1, except with oxygen and fluorine, and it is with oxygen here. And chlorine in this example is +4. And finally, the last one, similar to what we've done in question 3 there, we've now got 7 oxygens and they'll all be -2. That adds up to -14. Don't quite think I've got enough there. You've got 7, they're all -14. So oxygen is -2. And that means that chlorine must be +7 in this case. So chlorine is +7 because there's 2 of them. And those 2 must add up to -14. So the oxidation state of oxygen in number 4 is -2. Oxidation state of chlorine is +7. So constructing some half equations from an overall equation then. So let me just pick a chemical reaction, magnesium, reacting with oxygen to make magnesium oxide. I'll balance that equation. Now what we can do is we can just use the rules that we've just used to assign oxidation states. These are both elements at the start, so they have 0 oxidation state. MgO, well that's in group, oxygen is always -2, sorry, because it's always -2 in a compound except when it's with fluorine or peroxide. Magnesium is in group 2, it will be +2, and that makes sense because it has 0 charge, and they cancel out +2, -2. So what I can do now is do half equations. I'm going to show magnesium becoming magnesium 2+, and it's doing so by losing 2 electrons. We did this in an earlier task, and we can show O2 becoming O2-. Balance this out, and it's gaining 4 electrons. So we can see in this chemical reaction that magnesium is being oxidized from 0 to +2, and oxygen is being reduced from 0 to -2. So the reduced, you can see the oxidation number is going down for a reduction, and in oxidation, the oxidation number is going up because it's losing electrons. So we can see by the oxidation state whether it's been oxidized or reduced. Oxidation means the oxidation number is increasing because it's losing electrons, it's becoming more positive. And in reduction, your oxidation number is decreasing because you're gaining electrons and becoming more negative. So it's your turn then. So what you're going to do is have a go at assigning the oxidation states in question 1 and question 2. Once you've assigned your oxidation states, try and do your two half equations, one for oxidation and one for reduction. When you're ready, unpause the video. Okay, first one, you will identify that sodium has oxidation state 0, as does oxygen, because they're both elements. And in the products, oxygen is -2 and sodium is +1. So our half equation is going to show sodium going from sodium element to sodium positive, and that's oxidation. And the O2 is becoming O2 minus, must balance it, show it gaining those electrons, so that's a reduction. It's worth pointing out that you're always going to find an oxidation and a reduction. You're not going to find two oxidations or two reductions. If something is losing electrons, that means the other thing is gaining them. And finally, for question 2, chlorine is an element, so that's 0. Bromine is an element, that's 0. But in the compounds, we need to assign the oxidation states. Group 7 -1, group 1 +1. Chlorine is -1. Unless it's with oxygen, which it's not, it's with potassium, or fluorine, it's with potassium there. So we're now going to show half equations. We've got Cl2 becoming Cl minus. Balance it out, we need two Cl's on the right, and it's gaining an electron, but they're both gaining electrons, so it's 2 electrons. So that's going to show my reduction. So we can identify that Cl2 has been reduced here. Meanwhile, the Br is going from -1 to 0. It's quite tricky, that one. Nothing's actually happened to the potassium, look, so I'm ignoring the potassium. Bromine is losing electrons, and I've got to balance them out again, so I've got 2 Br minus. It's actually the complete opposite to what's happening to the chlorine. Chlorine is becoming chloride, while bromide becomes bromine. That's difficult, that. So Br minus has been oxidized. So Br minus has been oxidized from -1 to 0. It's losing electrons. And the chlorine is being reduced from chlorine to chloride from 0 to -1. This is quite tricky, but practice makes perfect here. Practice, practice, practice. Okay? Looking back at the spec then, we're almost finished with A2. So we've looked at oxidation, reduction, variable oxidation states. We have seen the variable oxidation states of chlorine, of transition metals. We will look a little bit more at that later on, but that's basically telling you that oxidation metals can exist as 2+ or 3+. So when we looked at group 1, it was just +1. When we looked at group 2, they were just +2. However, those transition metals in the middle can have variable oxidation states, which mean sometimes it can be +1, sometimes it can be +2. Iron, for example, can be +2 or +3. We don't need to know all the different states, we just need to be aware that transition metals can have different states. Okay, sometimes it's +5, and then in the same element in a different substance, it could be +3. So we're going to focus the final lesson next time on displacement reactions and the uses of and applications of this entire aim for summarising the full topic. Hopefully that was useful then. Again, I aim to get out some other revision videos as well to cover Learning Aim A1, and in the future also moving on to the physics and the biology as well.